Hello and welcome to CET 4884 Security Methods and Practice. In this session we will continue addressing security technology. At this point we learned about protecting companies' network through firewall technology, but most of the time you will have an intrusion that might happen. So if there was an intrusion, how can we detect that intrusion, and then how can we manage it or deal with it? Are there other prevention methods or systems that can be used to control the access to the organization's information? This session will address different prevention methods. People and technical controls are equally important in the protection of organization assets. Education or educating the people and implementing the technical controls should adhere to companies' policies and rules. All controls and training programs are trying to prevent intrusions. An intrusion is defined as a type of attack on information assets in which the instigator attempts to gain entry into a system or disrupt the normal operations of a system, with almost always the intent to do malicious harm. So what if an intrusion happens? Then an incident response plan has to be implemented, identifying and classifying the intrusion, then responding and recovering from the incident. The incident response is frequently discussed in terms of prevention, detection, reaction, and correction. So the intrusion prevention consists of activities that seek to deter any intrusion from occurring. In addition, it consists of procedures and systems that are created and operated to detect system intrusions. Intrusion reaction encompasses the actions an organization undertakes when an intrusion event is detected. Intrusion correction activities finalize the restoration of operations to a normal state, and by seeking to identify the source and method of the intrusion in order to ensure that the same type of attack cannot occur again. They return to intrusion prevention, thus closing the incident response loop. Intrusion detection systems actually detects a violation of its configuration and activates an alarm. So system administrators can choose the configuration of the various alerts and the associated alarm levels for each type of alert. Many IDSs enable administrator to configure the systems to notify them directly of trouble via email or pagers, or nowadays with text messaging. IDS systems can also be configured to notify an external security service organization of a break-in. Exactly the same as the security system that we install in homes. When you have an alarm or alert, that will be notified to the security system. Intrusion detection system includes a site policy that has rules and configuration guidelines governing the implementation and operation of IDSs within the organization. The ability to modify the site policies in reaction to environmental activities is called site policy awareness. When intrusion occurs, an alert or alarm will indicate that the system has been attacked or still under attack. Alarms could be triggered by false attack stimulus or true attack stimulus. False attack stimulus is an event that triggers alarms and causes a false positive when no actual attacks are in progress. False negative means the failure of an IDS system to react to an actual attack event, while false positive is an alarm or alert that indicates that an attack is in progress or that an attack has successfully occurred when in fact there was no such attack. True attack stimulus is an event that triggers alarms and causes an IDS to react as if a real attack is in progress. In some cases, the system will experience an ongoing activity from alarm events that are accurate and noteworthy, but not necessarily significant as potentially successful attacks. Such a case is called noise. They're making noise because it's ongoing activity, but it's not worthy to respond to. The system can use alarm filtering process to classify the attack alerts that an IDS produces in order to distinguish or sort false positives from actual attacks more efficiently. Actually, identical alarms that happen at close to the same time can be grouped into a single higher level alarm in a process called alarm clustering and compaction. The ability to detect the attack has a percentage of error, and the value associated with an IDS ability to detect and identify an attack correctly is called confidence value. In other words, how much are the calculation confident that there is an attack on the system, how accurate the calculations are. Why to use an IDS? What is the importance of using intrusion detection systems? Why do we need them? We use IDSs to prevent problem behaviors by increasing the perceived risk of discovery and punishment for those who would attack or otherwise abuse the system. It detects attacks and other security violations that are not prevented by other security measures. It detects and deals with the preamble to attacks. It documents the existing threat or threats to an organization. It acts as quality control for security design and administration, especially of large and complex enterprises. And it provides useful information about intrusions that do take place, allowing improved diagnosis, recovery, and correction of causative factors. As been stated previously, we have three types of intrusion detection methods: a network-based, host-based, or application-based systems. A network-based IDS is focused on protecting network information assets, while a host-based version is focused on protecting the server or host's information assets. The application-based model works on one or more host systems that support a single application and is oriented to defend that specific application from special forms of attack. The host IDPS examines the data in files stored on the host and alert system administrators of any changes, while the network IDPS examines packets on network and alerts administrators of unusual patterns. In the next few slides, we will address actually in details how each type works, including the advantages and disadvantages of both types. So for the network-based IDS, it resides on a computer or appliance that's connected to a segment of an organization's network and monitors network traffic on that network segment, looking for identification or indication of ongoing or successful attacks. When a situation occurs that the network-based IDS is programmed to recognize as an attack, it responds by sending notifications to administrators. When examining the packets transmitted through an organization's networks, an NIDS or network IDS looks for attack patterns within network traffic, such as large collections of related items that are of certain type, which could indicate that denial of service attack is underway, or the exchange of series of related packets in a certain pattern, which could indicate that a port scan is in progress. The network IDSs are installed at the specific place in the network, such as on the inside of an edge router, from where it's possible to watch the traffic going into and out of the particular network segment. The network IDSs can be deployed to watch a specific grouping of host computers on a specific network segment, or it may be installed to monitor all traffic between the systems that make up an entire network. The network IDS uses signature matching to determine whether or not an attack has occurred or may be underway. Of course, for the IDSs, it looks for attack patterns by comparing measured activities to known signatures in their knowledge base. We are comparing that signature that's coming for or with the signatures that we have in the database. They do this by comparing the captured network traffic using a special implementation of the TCP/IP stack that resembles the packets and applies or reassembles the packets and applies a protocol stack or application protocol verification. In the process of protocol stack verification, the network IDSs look for invalid data packets. In application protocol verification, the higher order protocols are examined for unexpected packet behavior or improper use. Some of the advantages of an IDS that it's good network design and placement of network IDS devices that can enable an organization to use a few devices to monitor a large network. And of course, for the network IDSs, they are usually passive devices and can be deployed into existing networks with little or no disruption to normal network operations. The network IDSs are not usually susceptible to direct attack and in fact may not be detectable by attackers. Some of the disadvantages: the network IDS can become overwhelmed by network volume and fail to recognize attacks it might otherwise have detected. They require access to all traffic to be monitored. They cannot analyze encrypted packets, making some of the network traffic invisible to the process. They cannot reliably or with reliability ascertain if an attack was successful or not. Some forms of attack are not easily desired or can be recognized by the IDSs, especially those involving fragmented packets. Part of the network intrusion detection and prevention system is monitoring the wireless network traffic and activities, especially that we have now wireless including to the wired technology. So we have both technologies implemented in the company or in the organization, and we need to monitor both. There are many issues associated with the wireless network, such as the physical security, sensor range, the access point and wireless switch locations, the wired network connections, and the cost of implementing the wireless. The intrusion detection examines network traffic in an effort to identify problems related to the flow of the traffic. Some of the events that could be detected through network behavior are the denial of service attacks, the TC port scanning, worms, unexpected application services, and policy violations. In the host-based IDS, it resides on a particular computer or server known as the host and monitors activity only on that system. The host IDSs are also known as system integrity verifiers, as they benchmark and monitor the status of key system files and detect when an intruder creates, modifies, or deletes monitored files. Most host IDSs work on the principle of configuration or change management, which means they record the sizes, locations, and other attributes of a system files. The host IDS then triggers an alert when one of the following changes occurs: file attribute change, new files are created, or existing files are deleted. The host IDS has an advantage over the network IDS in that it can usually be installed in such a way that it can access information that is encrypted when traveling over the network. The host IDS relies on the classification of files into various categories and then applies various notification actions depending on the rules in the host IDS configuration. Managed host IDSs can monitor multiple computers simultaneously by creating a configuration file on each monitored host and by making each host IDS report back to a master console system, which is usually located on the system administrator's computer. Some of the advantages of the host IDS is that it can detect local events on host systems and also detect attacks that may elude a network-based IDSs. The host IDSs or IDS functions on the host system where encrypted traffic will have been decrypted and is available for processing. And also the use of switched network protocols does not affect the host IDS, and that's one of the advantages compared to the network IDS. The host IDS can detect inconsistencies in how applications and systems programs were used by examining the records stored in audit logs. Some of the disadvantages of the host IDS is that it poses more management issues since they are configured and managed on each monitored host. They are vulnerable both to direct attacks and to attacks against the host operating system. They're not optimized to detect multi-host scanning, nor they are able to detect the scanning of non-host network devices such as routers or switches. The host IDS is susceptible to some denial of service attacks, and also they can use large amounts of disk space to retain the host OS audit logs. To function properly, it may require disk capacity to be added to the system. The host IDS can inflict a performance overhead on its host systems and in some cases may reduce system performance below acceptable levels. And this is the comparison between the network IDSs and the host IDSs, and each one of them has advantages and disadvantages, and at a certain point it will be up to the company, to the organization, to implement one of them or both types of intrusion detection. that will be all for this session. If you have any questions, please let me know. Thank you and have a great day.